VLAN pool introduction. So what is a VLAN pool? Multiple VLAN ID can be added to the VLAN pool that provided that the VLAN assignment algorithm. So you can able to see, right, like this one actually doing the same thing as the DHCP server. So as what we know, the DHCP server is going to create one IP pool, and we can set a certain range of the IP inside the IP pool. So for the VLAN pool, you're doing the same thing, but the only difference is they're not going to use an IP address. You're going to do the pool for the VLAN. This is explaining some of the problem for the VLAN. The live network face the following challenge. So when they have so many PC in the large range of the IP address, like example right now in some of the enterprise, they have so many concurrent user. So right now we already created one of the network segment and we using the subnet is 24. So that means I only have the valid range of the IP address, which is start from 1 all the way to 254. But what if the user actually is more than this number? So that means right now for this SSID, it can't match for the current requirement. For what we know, for all the SSID that we assign and let all the client to connect online, so they always will bind into the same VLAN. So in order to extend the VLAN range for all the client, we're going to use the VLAN pool. So everyone can able to connect to the same SSID without changing to the different SSID. So for the AC itself, it will do the auto arrangement based on its own VLAN pool. So like example, right now I create a VLAN 10, VLAN 20, and VLAN 30. I put all those VLAN belong to the same VLAN pool. So right now my VLAN 10 is already fully utilized by all the access user, and my AC is going to know. Now have a new user trying to connect to my same SSID, and they know right now the first VLAN 10 is already fully utilized, have no longer have any valid IP address to assign. So if we're going to send this access user to the new VLAN, like example VLAN 20, okay. So for the client, they didn't no need to worry about what is the network segment and what VLAN they're going to connect. So what they need to do is just connect to the SSID. That's all. So the VLAN pool can be used to assign a different VLAN to the SDS, reducing the broadcast domain size and the number of the broadcast packet, okay, thereby improving the network performance. So here I have some of the assignment algorithm of the VLAN in the VLAN pool. So we can able to divide it into two different types, the sequence-based and also the hash assignment. So the difference here, they already show you the comparison. The first one, this is belong to the sequence-based, and the second one is a hash assignment. So the advantage for the sequence-based assignment, all the STAs are evenly added to the VLAN. But for the disadvantage will be the different VLAN and the IP address might be assigned to the STA when they go online for multiple times. So the meaning of here is if you're using the sequence base, right, for the AC, you're not going to recognize the PC at all. So right now, like this moment, you're getting when you connect to this SSID and you try to go online, so you might getting the IP address of 10.1.1.1. After you go offline, then you come back again, you might not able to getting the same IP address and the same VLAN. So this is a reason over here. Okay. Then the next one is a hash assignment. So this assignment will based on the MAC address and assign the VLAN to the client. So you can see from the first one the advantage. The same VLAN and the IP address can be assigned to the STA that go online for the multiple time. So I don't care you're going to join and leave how many times, you're always getting the same VLAN and the same IP address. But the disadvantage is the STA are only add to the VLAN. So this is the only thing disadvantage for the hash assignment. The SDA will first going to choose what is the SSID they want to connect. So the SDA is trying to associate with the current AP. When the AP receives the associate message sent from the SDA, you're going to send it to the AC and check all the valid VLAN. Okay, you're going to bound to the VLAN pool. So the VLAN is assigned to the SDA based on the VLAN assignment algorithm. So you based on just now the two different algorithms. So either we're using the sequence based or we're using the hash based. Then they're going to assign the IP and also the VLAN to the client. So you can see the last one is the SDA go online through the assignment of the VLAN. So this is a way for us to configure the VLAN pool through the CLI. We're using the command from the system view here, VLAN pool followed by the name. So you can put any name on the pool name here. Okay. After that, it will bring you into the pool name here that you create. So from here, you need to give them the range of the VLAN that you want to use here. So example, like I mentioned just now, the VLAN 10, VLAN 20, and VLAN 30. So you can put VLAN space 10, space 20, space 30. So that means I only want to include VLAN 10, 20, and 30 into this VLAN pool. If I'm going to use the command VLAN space 10 dash 30, that means I want to include all the range from the VLAN 10 all the way to the VLAN 30. That means include 10, 11, 12, okay, 20, 21, 22, all the way to 30. So this is the range of the VLAN range. Then next, we can using the assignment command here to change the calculation. Okay, event or using the hash. Okay, we have two selections from here. Okay, next one, we can using the command quick, return to the system view, and type the WLAN to enter to the WLAN view here to apply this service VLAN. So from here, we're going to create the VIP profile. Okay, this VIP profile, if you are first time to create the VIP profile, you need to give a name here. Okay, for the second time, you don't need to using a profile name anymore. We can just using the ID and configure the profile. So this is a VIP profile. We're just using a command service VLAN. So for what we know, right, when we configure the service set, we always bind the service set into the single VLAN. So when you want to bind into the multiple VLAN, then we need to using the VLAN pool. So we're putting the service VLAN and then followed by the name that we could create here. Example here, I'm using the VLAN pool test or maybe Huawei. So I put service VLAN followed by VLAN dash pool space Huawei. So this is how I do that. In the content number 4 is a large-scale WLAN introduction. From the slide here, you can able to see how does the network design over here. You can see they have so many layer 2, layer 3 device, AC, and also the chassis type switch on the core layer. So they have so many over here. They're going to separate into 3 different parts. So the lowest one we call as the access layer. Then we go up one more layer is called aggregation layer. And the last layer on the top one, they're called as a core layer. So they're using one of the high-end model, and we call as an agile switch in the Huawei, okay, S12000, 7000 series. The network design will depend how we're going to do that. Okay, right here we have the direct and dynamic forwarding mode. So the direct forwarding is one of the forwarding mode for all the user data. Okay, for all the connection between the AP and AC, we'll call as the control frame. Those kind of control frame we always using the CAPWAP donor and send through the network. Doesn't matter it's layer 2 or layer 3 from AP to AC. But for the user data, we call it as a data frame. For those kind of data frame, right, it will depend on what kind of forwarding mode that we select. If we go into using the direct forwarding, this means all the user data is no need to go back to the AC before they go online. For the tunnel forwarding mode, you're going to force all the user data, no matter the user data can actually go online or not, they always need to send back to the AC before they can go online. Okay, this is called the tunnel forwarding mode. So they use a tunnel that form from the AP and the AC. Okay, here is the specification comparison. So for us to using the AC to manage all the AP, we have few ways. So the first one, if we're using the chassis switch, we can using the ACU2 to manage the AP, or we can using the native AC to do that. So the AC6605 belong to the box switch. Okay, the first two is belong to the chassis. So you can see the comparison from here. When we're using the ACU2, this one is the number of port, right? This is a dumb card with a port. For the native AC, they have a multiple port. For the box one, this one is belong to the independent AC with a multiple ports because this is a box switch. So when you try to compare with the forwarding capacity, of course the chassis got a higher forwarding capacity. So as you can see, the ACU2, they're able to support up to 40 gig. For the native AC, can support 70 meg wireless CAPWAP centralized forwarding capacity is 30 megs. For the box is only up to 10 gig. So below here have the control plane. Okay, number of AP. So here you have the large difference when you're trying to compare the chassis and the box. The box AP maximum can up to 1000. But when we go to the chassis and we're going to use the ACO2 here, so we can able to make support up to 2000 AP per card. So that means one card allow you to manage up to 2000. So the entire device, right, will depend on how many of the ACU card you purchase. So it becomes the number of the card you're using here times 2000. So here go for the native AC. They only can support 1000 AP. For the entire device capacity is 4000 only. So they also have the number of the SDA. How many of the access user, right, they can able to manage. So this access user will be the client they're trying to connect and managed by the AC itself. So the ACO can able to support up to 64,000. So and this one will be same to the native AC. But for the box AC, the maximum only can support up to 10,000. So you can see from here, most of them can support the redundant. So this is about all the specification comparison between the ACO, native AC, and the AC6605. So here is the application scenario for the three type of the AC. Independent AC card. So it is more suitable for the large-scale network that require capacity expansion in the future and have the insufficient rack slot resource. It's more for the future use, so they can keep expanding their network depend on what they need. So that's why they're going to using this card. Native AC. This kind of the AC is suitable for the combination of the wire and also the wireless network. And lastly is the independent box AC. So applicable to overlay the network where wire user and the SCA are separately managed. So just now is just the introduction for all the WLAN. Now we go into the configuration example. So you can see the picture over here. They have a before and after, how we're going to actually set up the design for the network diagram. So here they have a one router and few equipment here. Okay, let us see the difference from here. So they already highlight out all the port number and also the VLAN on the picture number 2. So we need to know, right, all the communication between the switch to the AC. So from here, then we know right now the AC and the switch, right, they're running the VLAN 200. So AC is going to use the VLAN 200 become its own management VLAN later on. Then at the middle here, you can able to see, okay, this is the layer we call as the aggregation layer, or you can call as an access layer, because anyway, this network layer, they only have two layers. Okay, so from here, you can see they have a VLAN 100, 101, 102. And on the other side, you have a separate VLAN. Okay, of course, 100 still remaining. 103 and 104 is for another side. So the left and the right, they're running a two different VLAN, except the VLAN 10. So from here, we can guess the VLAN 10, the VLAN 100 also is belong to the management VLAN. So right now, AP, you're going to use all the VLAN 100 for the AP. The AC, you're going to use the VLAN 200 as its own management VLAN. So this kind of network we'll call it a layer 3 network. So in this case, we have to using the option 43 to change the index inside the DHCP server. Okay, so all of those, right, is the configuration on the physical port. So as you can see, the port here, they already mentioned port number 4 and port number 3 is showing you how to configure the trunk link. So normally for what we know, when we want to configure the VLAN, you have to some understanding about the VLAN configuration. So like when you're going to configure as a access port and when you're going to configure as a trunk port. So this one is the usage scenario. On the large scale WLAN, okay, S12000 series is one of the Huawei Angel switch. Okay, it's deployed as the core switch. And the AC6605 is connected to the 12700 to manage all the AP on the network. The next one is a 5000 series. So this one is one of the layer 3 switch in the Huawei. Okay, are deployed as an access switch. The 5700 connect to the AP to supply the power for the AP through the PoE and connected to the 12700. So actually this one is referred back to the previous slide here. So as you can see, this is the core switch. All right, it's using this model 12700. And just now I mentioned the AC is actually connected to the core switch here. So below here is belong to the access switch. So why they're going to use these two model? Because they actually these two models belong to the PoE switch. So they require using the PoE to power up all the AP. So this is the reason why you can see over here they have two switch. APs connect to S5700. One, the first switch, and the second switch are deployed in the office building 1 and 2 respectively